The ratio of two edges of two regular hexagonal prisms is 5 to 4. Find the ratio of their volumes and the ratio of their areas. Okay, so we're going to have two regular hexagonal prisms. We're going to label each side A for this one since it's regular. And the one on the right is going to be 5 to 4 times bigger. So we're going to let each side be 5/4 A. Okay, so now let's look at the volume and the area. So first, how do you find the volume? The volume is the area of the base times the height. So the base is a hexagon, and it's a regular hexagon. So for regular hexagons, we can break it up into 6 equilateral triangles. The area of each triangle is going to be √3/4 times the side length squared. And because there's 6 of them, we're going to multiply each area of the triangle by 6 to get 3/2 times √3s squared. For the first rectangular prism, the side length is A. So the area of the base becomes 3√3/2 A squared times the height. The height is also A since a regular hexagonal prism. So that would just be 3√3/2 A cubed. The second hexagonal prism, we're still going to be using the same formula, except instead of A, the side length is 5/4 A. So it'll still be 3/2√3, but we're going to replace A with 5/4 A. So that would be 3√3/2 and then 5/4 A cubed. So 5 cubed is 125 times 3 is 375. And then 4 cubed is 64 times 2 is 128. And so that's the volume for the second one. Okay, so now we want to look at the ratio. So I'm going to divide these two. I'm going to put the top one, the big one on the top and the smaller one on the bottom. Okay, let's see. The A cubes are going to cancel. So is the √3. I'm left with 375 over 128 divided by 3/2. The same thing as multiplying by 2/3. That's going to be 64. That's going to be 125. So that's going to be 125 over 64. So the ratio of the big one to the small one will be 125 over 64. So that's for the volume. For the area, we'll be looking at the surface area. So in this case, for the surface area, we want to find the area of the base, the two bases, so the top and the bottom, plus the 6 faces, so like these rectangles over here. So let's write that down. So the area is going to be twice the base, area of the base, plus the 6 faces. So I'm going to put 6 faces here. Okay. All right, so let's look at this. For the first one, the area of the base we already did. That's going to be √3/2 A squared. The 6 faces, well, each face is a rectangle, which actually in this case technically is a square because they have length A by A. So that's going to be 6 times A squared. Okay, I can simplify this. The 2's are going to cancel. I'm left with 3√3 A squared plus 6A squared. I can factor out a 3A squared. to get root 3 plus 2. So that's the area of the smaller one. For the bigger one, we're going to replace a with 5/4 a. So I'm just going to look at the same formula on the left here. So we're going to replace it with 5/4 a. And the 2's are going to cancel. So I have 5/4 squared will be 25 over 16 times 3 is 75 over 16 root 3 a squared. 5/4 squared is 25 over 16 times 6 is 150 over 16 a squared. I can factor out a 75 over 16 a squared. What's left is root 3 plus 2. Now I'm left to look at the ratio of these two. I'm going to let the top one be the bigger one. And the smaller one be on the bottom. Root 3 plus 2 is going to cancel. A squared is going to cancel. So I'm left with 75 over 16 divided by 3, which is the same thing as multiplying by 1/3. 75 is going to turn into 25. 3 is going to turn into 1. And the ratio is 25 over 16, which is, I believe, the same one as the volume. Okay. All right, let's look at another problem. Okay. So the next one, we're looking at a circle. So the center is here. We have points A and B. The angle here, the central angle, is 60 degrees. The radius is 5. I want to find the length of arc AB, the diameter, the area of the circle, and the area of the sector. So first, the arc AB is going to have the same angle as this one, since that is a central angle. The diameter is twice the radius. The radius here is 5, so that's going to be 10. The area of the circle, well, the area of the circle is pi r squared, which here the radius is 5, so that would just be 25 pi. The area of a sector, you're still going to use pi r squared, except you want to take your angle and divide it by 360. So this sector, this whole thing, represents 60 over 360th of a circle. In other words, 1/6 of a circle. So taking the area of that sector is the same thing as taking the area of 1/6 of the circle. So that'd be 1/6 times 25 pi. So that'd just be 25 pi over 6. Okay. And that's the area of the sector. Okay. Okay, in this one I want to find arc DA, angle B, so measure angle B, and measure angle E. Okay. So first thing to notice is DAC is half a circle, right? Because it goes through the center there. So because that's half a circle, the whole thing is going to be 180 degrees. So that leaves this portion here. So that in the red plus 50 will have to be the whole 180 degrees. So this has to be 130. Measure angle B will be 1/2 the difference of 130 and 50. So that would just be 40 degrees. Measure angle E. Well, let's look at what measure angle E is. That arc for measure angle E is the arc DAC. DAC is half of the circle. So measure angle E is going to be half of the arc DAC, which DAC we said is 180 degrees. So that would just be 90 degrees. So this thing is a right angle. Okay. All right. Let's look at another one. Given another circle. So we have two tangent lines. Like that, so. And then we're going to have a secant line. Okay, so we're given DC is 8. BC is 4. I want to find the length AC and CF. Okay. So first, I'm just going to look at AC and DC. Okay. So I'm just going to redraw it. So let me just redraw this. Whenever you have a secant and a tangent, the formula is going to be the whole thing AC times BC that is going to equal DC squared. So it's this whole thing times this thing equals this thing squared. So you're always going to square the tangent one. Okay. So AC is the length of the whole thing. So we know that BC is 4, DC is 8. So I'm just going to let AB be x in this case. So AC then is going to be x plus 4. BC is 4. DC is 8. So I have x plus 4, which is AC, times 4 is 64. And that means x plus 4 is 16. Okay. Which x plus 4 is equal to AC, and we have a first answer here. AC is 16. So if I want, I can solve for x to get 12. But I don't have to do that because I know AC is x plus 4, which is 16. So the next thing is figuring out what CF is. So the CF, I claim that you don't have to do any work because you know the answer is going to be 8. And here's a way to prove it. So let's go on the side here. So I have C and okay, F and D. Okay, so let's say I have a center here. If I draw these lines, and I draw another line here, so these are going to be congruent with the center because that's the radius. Okay, so FO and OD are the radius, so they're going to be congruent. OC is congruent to itself, and FC and DC are tangents, so that means they're going to form a 90-degree angle. So these triangles are going to be congruent by HL. Okay, the hypotenuse is OC. The two legs are FO and OD. And so those are congruent. Okay. So OC is congruent by itself. Reflexive property, FO is congruent to OD since the radius. So those are going to be congruent. That means by CP/CTC, FC is congruent to DC. Okay, so we had DC as 8. That means FC also has to be 8. Okay. So that completes this problem. Okay. A circle has a radius of 10 and a chord of length 12. Find the distance from the center to the chord. So I have a chord here, length 12, center with radius 10. I want to find the length of the chord to the center. So the distance is going to be represented by a perpendicular line, because the distance between a point and a line, you draw perpendicular. So I'm going to draw this out like this. These are going to be congruent because they're going to be the radius of the circle. So it's like the point from the center to the edge of the circle. It's going to be congruent. So I end up having an isosceles triangle. And we know that the perpendicular here is going to break it up into two congruent pieces. So that's one of the properties of the altitude of an isosceles triangle. So if the whole length is 12, that means each one is going to be 6. The radius is going to be 10, so that's going to be the hypotenuse here. This one is going to be a 3, 4, 5 triangle. I have 6, I have 10. That means the missing side is going to be 8. So the distance is going to be 8 in this case. Okay, and last one. I'm given a cube, length 6. I want to find the volume, total area, and diagonal of the cube. So for the volume, it's just going to be S cubed, which is 6 cubed, and that's 216. That one's pretty simple. The surface area, or the total area, is the adding up all the areas of the faces. So there's 6 faces. The area of each face is 6 squared. Okay, so it's 6 by 6 each one of these. So that's again 216. The diagonal is a bit tricky. So what we're going to do, let me just redraw this. We're going to connect the bottom corner here with the top corner. That's going to be the diagonal that we're looking for. So the way to do that is to look at this diagonal. So we're looking at the base here, the diagonal here, and then this height here. That forms a 90-degree angle. Okay. So we know that the height is 6. What is the diagonal here of the base? Well, if I were to look at a bird's eye view of the base, I have 6, 6, and then I want to find the diagonal. The diagonal is going to be 6 root 2. So now I have a right triangle. The base of it is 6 root 2, the height is 6, and I want to find the hypotenuse. So I'm going to do the Pythagorean theorem. So I have 6 root 2 squared plus 6 squared is going to be c squared. So that's 72 plus 36 is c squared, which is 108 equals c squared. And c is going to be 6 root 3. Okay, and so the diagonal in this case is 6 root 3.